paper. Today we have to do October November 2022 paper 2 variant 2. By October November 2022 paper 2 variant 2 1 hour 45 minutes का पेपर है ये. We have to start with this. चलो, let's move ahead. A train travels along a straight horizontal track at time t is equals to 0. The train passes through station P at constant speed without stopping. Perfect. The driver applies the brake 70 seconds before reaching station Q. Okay, so the
कौन
driver,
से पेपर पे?
we are doing October November 2022 paper 2 variant 2. So a train travels along a straight horizontal track at time t is equals to 0. The train passes through station P at a constant speed without stopping. Perfect. The driver applies brakes 70 seconds before reaching station Q. Perfect. So 70 seconds before reaching station Q, the driver applies brake, the train decelerates. Perfect. Figure 1.1 is the speed time graph for the train from time t is equals to 0 until it stops at station Q. Perfect. From time t is equals to 0 till this, we have the speed time graph. Perfect. Use figure 1.1 to determine the distance between station P and Q. We have to use figure 1.1 to determine the distance between station P and Q. You have to remember what? You have to remember that area under speed time graph is equals to your distance. Perfect. Area under speed time graph is equals to your distance. So this area will be your distance traveled. This area will be your distance traveled. How can you calculate this distance traveled? By calculating the area of a trapezium. What is the formula of area of trapezium? 1 upon 2 into sum of parallel sides. What are the parallel sides here? This one and this one. These two are the parallel sides here. Perfect. What is the value of this parallel side? What is the value of this yellow parallel side? This is 56. What is the value of this blue parallel side? This is 126. Perfect. तो बेटा आपके पास पैरेलल साइड्स आ गई. Perfect. You have the parallel sides. What will you do? You will add them up. 56 plus 126. What is the height? What is the height? The height is this middle value. This between 60 and 80. This will be 70. This will become 77. The height is 77. Can you calculate the distance traveled by the car between station P and Q? Can you calculate the distance traveled by the car between station P and Q? सिर्फ calculator में डालना है बेटा and you will get the answer. The distance comes out to be what? The distance comes out to be 7,000 meter. The distance comes out to be 7,000 meter. Simple as that. Nothing complicated here. सर 7007 नहीं आ रहा बेटा. 7007 ही आ रहा है बट मैंने टू सिग्निफिकेंट फिगर्स पे राउंड ऑफ कर दिया. 7007 मीटर्स को अगर मैं टू सिग्निफिकेंट फिगर्स पे राउंड ऑफ करूंगा व्हाट विल योर आंसर बिकम? ये थर्ड फिगर क्या है? 0. सिंपल. द मास ऑफ द ट्रेन इज 3.8 into 10 raised to the power of 5 kg per fare. Determine the deceleration of the train in the 70 seconds before it stops at station Q. बेटा आपने deceleration निकालनी है. Now what do you remember? What do you remember? The gradient of velocity time graph is equals to your deceleration. The gradient of velocity time graph is equals to your deceleration. Perfect. So देखो, ये बहुत दफा डिस्कस हुआ है कि अगर किधर गया यार. अच्छा, अब अगर कोई कहता है सर कि मैं ये 7007 मीटर्स का आंसर लिख के आ गया हूँ, तो विल इट बी मार्क करेक्ट और नॉट? इट विल नॉट बी मार्क करेक्ट. It will be not marked correct. It will not be marked correct. Why? Because this is four significant figures. This is four significant. However, अगर आप इसको थ्री सिग्निफिकेंट फिगर्स पे राउंड ऑफ कर दो, Let's say you write your answer as 7010 meter. तो ये थ्री सिग्निफिकेंट फिगर्स पे राउंड ऑफ हुआ हुआ है. दिस विल बी करेक्ट एज वेल, दिस विल बी करेक्ट एज वेल, दिस विल बी इनकरेक्ट. ओके, चलो लेट्स मूव अहेड. The mass of the train is this. Determine the deceleration of the train in the 70 seconds before it stops at station Q. We have to determine the deceleration. Now, do you guys remember a key point? Do you guys remember a key point? That the gradient of velocity time graph is equals to what? Acceleration or deceleration. The gradient of velocity time graph is equals to what? Acceleration or deceleration. So we are going to calculate the deceleration or gradient of this portion of the line. We are going to calculate the acceleration or deceleration of this portion of the line. Perfect. So let's zoom in a bit. Let's zoom in a bit. So if you see here, you have 2 points. This is your first point, that is 56. Y-axis is 77. What is the second point? The second point is this. One second. This is 126 slash 0. Can you calculate the gradient of this graph? Can you calculate the gradient of this graph? Yes, 0 minus 77 divided by 126 minus 56. What does your answer come out to be? Negative 77 divided by 70. Your deceleration comes out to be what? Negative 1.1 ms minus 2. Your deceleration comes out to be what? Negative 1.1 ms minus 2. बेटा आप थोड़ी सी अपनी इंग्लिश पे भी फोकस करना, ठीक है? थोड़ी सी इंग्लिश का एग्जाम भी दे रहे होगे तो हेयर यू हैव टू कैलकुलेट द डीसैलरेशन. डीसैलरेशन का आंसर स्टेट करते हुए यू हैव ऑलरेडी इनकॉर्पोरेटेड द नेगेटिव साइन. You will just write the magnitude here 1.1 ms minus 2. Perfect. Calculate the resultant force on the train as it decelerates. You have to calculate the resultant force on the train as it decelerates. You will have to calculate the resultant force on the train as it decelerates. Resultant force is equals to mass into acceleration. What is the mass? 3.8 into 10 raised to the power of 5. What is the deceleration? 1.1. Can you calculate the resultant force? बेटा resultant force निकाल सकते हो. Yeah, this comes out to be what? 4.2 into 10 raised to the power of 5 Newton. Let's further move ahead. Let's further move ahead. The foundation that supports a building are long concrete cylinders that are pointed at one end. A pile driver is a machine that forces the pointed concrete cylinders into the ground surface. A pile driver is a machine that forces the concrete cylinders into the ground surface. Figure 2.1 shows a pile driver. Perfect. Figure 2.1 shows a pile driver. A heavy block of mass 2.9 into 10 raised to the power of 4 kg is lifted into air, then dropped onto the top of a concrete cylinder. This force this forces the cylinder into the ground. Perfect. Figure 2.2 shows the heavy metal block. Okay, so we have this heavy metal block that is forced onto these concrete cylinders. this वजह से ये नीचे पुश इन होना शुरू हो जाते हैं. Perfect. Let's mark some important points. You have the mass as 2.9 into 10 raised to the power of 4. This is how the heavy blocks look. The heavy block is 2 meter tall and has a cross sectional area of this. Perfect. Calculate the density of the material used to make the block. What is the formula of density? Density is equals to mass over volume. What is the mass? 2.9 into 10 raised to the power of 4. What is the volume? Area into the height. What does your density comes out to be? 2.9 into 10 raised to the power of 4 divided by 3.6. What does your density comes out to be? बेटा डेंसिटी किसके इक्वल आ जाती है? 8.1 इंटू 10 इज द पावर ऑफ 3. 8.1 into 10 raised to the power of 3 kg ms minus 3. This is your answer. अच्छा. किसी का सवाल है? अगर वो रिटार्डेशन कहता तो बेटा अगर रिटार्डेशन कहता तो भी आप साइन इग्नोर करते। अगर रिटार्डेशन कहता बेटा तो भी आप साइन इग्नोर करते। चलो लेट्स मूव अहेड। द पाइल ड्राइवर lifts the block from the top of a concrete cylinder through a height of this। अच्छा इतनी हाइट पे लिफ्ट कर रहे हो, perfect। The gravitation field strength is 10, perfect। Calculate the gravitational potential energy gained by the block। How will you calculate the gravitational potential energy? mgh। What is the mass of the block? What is the mass of the block? 2.9 into 10 raised to the power of 4। 2.9 into 10 raised to the power of 4। What is gravitation field distance? 10। What is the height? 0.8। Can you calculate gravitational potential energy? Can you calculate gravitational potential energy? Yeah, that is 2.3 into 10 raised to the power of 5। 2.3 into 10 raised to the power of 5 joules is your gravitational potential energy। Nothing complicated। परफेक्ट है, चलो अल्हम्दुलिल्लाह। अच्छा दूसरा सवाल क्या था भाई? Someone was asking sir, हाँ, you can write it like that as well, perfect। The block is then dropped from a rest onto the top of a concrete cylinder, perfect। Calculate the speed of the block just before it hits the concrete cylinder। बेटा देखो हो क्या रहा है, analyze what is happening। Your concrete block is at a height, and at this point it will have some amount of gravitational potential energy। However, at this point it is at rest as well। However, it is at rest as well. That means kinetic energy will be equal to 0। However, at this point the velocity is 0. That means kinetic energy will also be 0। However, as you move downward, what will happen? Gravitational potential energy will get converted into kinetic energy। As you move downward, gravitational potential energy will get converted into kinetic energy। तो हम क्या करने वाले हैं इधर? What are we going to do here? We will simply say, we will simply say that the gravitational potential energy is equals to the kinetic energy of the block। What is the gravitational potential energy? 2.3 into 10 raised to the power of 5। 2.3 into 10 raised to the power of 5। What is the kinetic energy? We don't know। 1 upon 2 into the mass. What is the mass? Were we given the mass of the block? Yeah, the mass of the block was 2.9 into 10 raised to the power of 4। Mass of the block was 2.9 into 10 raised to the power of 4। So let's write it 2.9 into 10 raised to the power of 4 into velocity square। Can you calculate the value of velocity? Yes, velocity की value comes out to be what? 4 ms minus 1। The value of velocity comes out to be 4 ms minus 1। Is this question clear to all of you, top to bottom? Question clear है बेटा, फिर आगे बढ़ते हैं। बताओ जरा, is this question clear? परफेक्ट है, चलो आगे बढ़ते हैं। लेट्स मूव अहेड। Okay. Figure 3.1 shows a man standing underneath an outdoor heater on a cold evening. Perfect. So this is a man standing under an outdoor heater on a cold evening. Perfect. Gas in the cylinder at the base of the heater is the fuel for the heater. Perfect. When the heater is operating, the gas travels to the top of the heater where it burns. Perfect. Gas in the cylinder at the base of the heater is the fuel for the heater। ठीक है बेटा, यहाँ पे गैस सिलेंडर में जो गैस है, दिस इज द फ्यूल फॉर द हीटर। परफेक्ट। नाउ no, if you listen, what will happen when the heater is operating? The gas travels to the top of the heater where it burns। the top of the heater पे चली जाती है where it burns। perfect। state the form of energy stored in the gas that is transferred by the heater। बेटा गैस में कौन सी फॉर्म ऑफ एनर्जी स्टोर होगी? डू यू रिमेम्बर? गैस, फ्यूल, पेट्रोल, बैटरी, हर चीज में कौन सी एनर्जी स्टोर होती है? केमिकल एनर्जी। केमिकल एनर्जी। लेट्स फिर देन मूव अहेड। A metal screen surrounding the burning gas is heated by the burning gas until it is red hot. Perfect. The hot metal screen warms the man who is standing underneath it. ठीक है. The hot metal screen warms the man that is standing underneath it. ठीक है. Metal screen को देख लेते हैं. Uh, okay, so where is the metal? Okay, so this is the metal screen, entire thing. Perfect. This entire thing is the metal screen. Perfect. So this metal screen is surrounding what? It is surrounding the burning gas. Okay. The hot metal screen warms the man who is standing underneath. Perfect. Describe how thermal energy in the red hot metal screen is transferred to the man and how it warms him. Beta, thermal energy, how does it transfer to the man and how does it warms him? So what will we say? What will we say? Infrared radiations are emitted from the red hot metal screen. The infrared radiation travel to the man. The man absorbs these infrared radiation and the internal energy of the man increases. You will write it in a very beautiful manner. You will say infrared radiations, infrared radiations are emitted, are emitted from what? Are emitted from the red hot metal screen, red hot metal screen. Perfect. These infrared radiations, these infrared radiations travel to the man, travel to the man and are absorbed by the man and are absorbed by the man. Perfect. This causes this causes the internal energy of the man to increase. This causes the internal energy of the man to increase. Of the man to increase. Perfect. Let's further move ahead. At the top of a heater is a metal hood that has a shiny lower surface. Perfect. So we have a shiny lower surface. Perfect. Explain why this makes the energy transfer from the metal screen more efficient. बेटा शाइनी सरफेस एनर्जी ट्रांसफर को मोर एफिशिएंट क्यों बनाएगा? Why will the shiny surface make the energy transfer more efficient? Because shiny surfaces are good reflectors of infrared radiations. Or you can say less thermal energy will escape. You can say shiny surfaces. You can say shiny surfaces are good reflectors, are good reflectors of infrared radiations, of infrared radiations. Hence, less thermal energy, less thermal energy escapes into the surrounding, escapes into the surrounding. Simple as that. Let's further move ahead. The air temperature decreases. Air temperature. Air
They're good
temperature.
conductors.
क्या कह रहे हो? नहीं समझ आई मुझे क्या कह रहे हो, तुम्हारी आवाज कट गई भाई.
चार्ट में लिखा है।
अच्छा अच्छा अच्छा, एक सेकंड एक सेकंड. शाइनी सरफेसेस. नहीं भाई, ये किसने कहा है भाई? ये किसने कहा है शाइनी सरफेसेस आर गुड कंडक्टर? ये कौन कह रहा है? ये कौन कहता है? सर कैन यू से हॉट एयर? ना. नहीं नहीं, यू कैन नॉट से दैट, दूर है ना. ये बड़ी
सर
ही. हाँ हाँ.
सर मैंने एहतियातन दोनों चीजें लिख दी थी कि वो रिफ्लेक्ट कर देता है
हाँ.
और वो लॉस लूज नहीं होने देता थर्मल एनर्जी, और दूसरा लिख दिया कि वो खुद भी एब्जॉर्ब नहीं करता, तो वो
पुअर
नीचे ही
एब्जॉर्बर,
रहता
पुअर एब्जॉर्बर, या गुड. बेटा शाइनी सरफेसेस, रयान सुन लो बेटा और बाकी सारे भी, शाइनी सरफेसेस आर पुअर एब्जॉर्बर्स, दे आर नॉट गुड कंडक्टर्स। किसने कह दिया भाई? ये गुड कंडक्टर्स कहाँ लिखा हुआ? पढ़ लिया ये? नोट्स में भी कहीं नहीं लिखा हुआ, ना मार्किंग स्कीम में कहीं लिखा हुआ है शाइनी सरफेस आर पुअर एब्जॉर्बर्स, ये लिखा होता है हर जगह। अच्छा, एंड दे आर गुड रिफ्लेक्टर्स, शाइनी सरफेसेस आर पुअर एब्जॉर्बर्स एंड गुड रिफ्लेक्टर्स। अच्छा, बाकी एक और बच्चे का सवाल था यहाँ पे कि, एक और बच्चे का सवाल था, सर हम ये लिख सकते हैं कि हॉट एयर राइजेज एंड इट डिफ्लेक्ट डाउन। बेटा ये तो बहुत ऑब्वियस बात है, ये क्यों लिखोगे? आपने बताना है कि शाइनी लोअर सरफेस की वजह से एफिशिएंसी क्यों इंक्रीज हो रही है। देखो, आपने बताना है कि आपका जो दाल चावल है वो अच्छा क्यों बना है, और आप बात कर रहे हो अबाउट द रेसिपी ऑफ बिरयानी, ये वाली बात हो गई है। यहाँ पे वो कह रहा है कि एफिशिएंसी क्यों इंक्रीज हो रही है ड्यू टू शाइनी लोअर सरफेस, और आप उसको कन्वेक्शन का प्रोसेस बता रहे हो। तो ऐसा तो नहीं चलेगा ना, एग्जामिनर तो ऐसे रट्टे मारने वाले सवाल थोड़ी देता है, मैट्रिक सिस्टम थोड़ी है। चलो, चलो, डोंट राइस का है, नहीं नहीं, इसे हॉट डोंट राइस, ना 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 ना, ये भी सही नहीं होगा, ये भी सही नहीं होगा। स्पेशली उसने कहा है कि शाइनी सरफेस से क्या फायदा होगा, स्पेशली उसने कहा है कि शाइनी सरफेस से क्या फायदा होना है बेटा, तो आपने उसको स्पेशली सिर्फ शाइनी सरफेस का फायदा बताना है। द एयर टेम्परेचर डिक्रीजेज एंड द मैन पुट्स ऑन अ ब्लैक पुलोवर। अच्छा, अब देखो, सवाल को इंटरप्रेट करना सीखो बेटा। एयर टेम्परेचर डिक्रीज हो रहा है, द मैन पुल्स ओवर अ ब्लैक पुलोवर। अब आपने बताना होगा कि ब्लैक पुल ओवर किस तरह उसको वार्म रखता है। अब यहाँ पे आप ये नहीं कहोगे कि शाइनी सरफेसेस आर पुअर एब्जॉर्बर्स, अब यहाँ पे आप शाइनी सरफेसेस की बात ही नहीं जिक्र करोगे, क्योंकि आपको ब्लैक सरफेसेस के बारे में बताना है। यू हैव टू टेल हाउ द ब्लैक पुल ओवर हेल्प्स टू कीप द मैन वार्म। तो ब्लैक surfaces are good absorbers and poor reflectors of infrared radiation. Hence, more thermal energy is absorbed. So you will say black surfaces. देखो, थोड़ा सा ना जो एग्जामिनर पूछा करे उसको ही वो जवाब दिया करो। Black surfaces are good absorbers and poor reflectors of thermal energy. Of thermal energy. I think I have taken a darker pen here. Let's shift to the lighter one. Black surfaces are good absorbers and poor reflector of thermal energy. Hence, more thermal energy is absorbed. Hence, more thermal energy is absorbed. Simple as that. Nothing complicated here. बैड emitter नहीं ना, बैड emitter नहीं कह सकते ना। ब्लैक surfaces आर गुड एब्जॉर्बर्स एंड गुड emitters, ये बात याद रखो, ब्लैक surfaces आर गुड एब्जॉर्बर्स एंड गुड emitters। तो वो नहीं लिख सकते बैड
सर
emitter।
एक दफा सिर्फ रिवाइज करने के लिए जो चारों थे सरफेसेस और कलर्स, वाइट ब्लैक डार्क लाइट,
हम्म।
उनका एक दफा बस बता दे कि वो इमेज कौन सा अच्छा करता है सबसे बेहतर, लाइक।
अगर आपका सरफेस डल है और ब्लैक है, दिस विल बी व्हाट, दिस विल बी अ गुड absorber and a good emitter. However, if your surface is shiny and white, then you will be a poor absorber and poor emitter. Simple as that. Let's further move ahead. अब आगे आ जाओ। A sound traveling in air or water contains compression and rarefactions. Describe an experiment to show that a medium is required to transmit sound. You may draw a label diagram if you wish. Now you have to tell about an experiment to show that sound requires a medium to travel. Now, if you open the notes, मैं notes में दिखा देता हूँ ये because making this again will require too much time. Basically, if you open the notes of sound, you will see one experiment. बेटा अगर आप साउंड के नोट्स ओपन करोगे तो यू विल सी वन वेरी इंटरेस्टिंग एक्सपेरिमेंट that I have quoted as bell jar experiment. That I have quoted as bell jar experiment. Here you have it. You have to write this experiment to show that sound requires a medium, whereas light does not require a medium to travel. What will you do in this experiment? You will say initially only air is present in the bell jar. Hence, when you ring the bell, you can hear the sound. Now, when air is removed using a vacuum pump, बेटा जब आप air remove करोगे using a vacuum pump, all this air inside the bell jar will be sucked out. This will create a vacuum, and hence, when you now ring the bell, there will be no sound heard. There will be no sound heard. When you now ring the bell, there will be no sound heard. Simple as that. ये बात समझ आ गई. You have to write this experiment. Nothing complicated. शाबाश रेयान. Very good. बेल जार experiment. जब तुम लोगों को चीज़ें याद होती हैं, it really feels very good inside. Very good. शाबाश भाई. When a sound wave passes through air or water, the molecules of the air or water move. Perfect. Describe the motion of the molecules due to the sound wave. You have to describe the motion of the molecules due to sound wave. Now, if you remember, sound waves are longitudinal waves. If you remember, sound waves are longitudinal waves. What will happen? The molecules vibrate in parallel to the direction of propagation. You will say molecules vibrate parallel to the direction of propagation. Molecules vibrate parallel to the direction of propagation. To the direction of propagation. Simple. To the direction of propagation.
सर प्रोपेगेशन क्या होता है?
Propagation wave travel. वेव ट्रैवल लिखना चाहते हो यहाँ पे वेव ट्रैवल लिख दो. ठीक है. प्रोपगेशन रीसेंट मार्किंग स्कीम में वेव ट्रैवल की जगह प्रोपगेशन ने कहा है, सो आई हैव यूज दिस प्रोपगेशन का वर्ड हियर एंड इट इज एडवाइजेबल कि आप लोग भी प्रोपगेशन का ही वर्ड यूज करो इंस्टेड ऑफ वेव ट्रैवल. डिस्क्राइब व्हाट इज मेंट बाय रेयरफैक्शन. What is meant by rarefaction? Points with minimum pressure. Points where molecules are at minimum pressure, or you can say points where molecules are further apart. You can say points where molecules are further apart. Where molecules are further apart. Simple as that. Let's further move ahead. Let's see this. Figure 4.1 shows a dolphin. Perfect. This is a cute little dolphin. Very good. The range of audible frequencies for the dolphin is this. Perfect. The speed of sound is this. Perfect. Calculate the smallest wavelength of sound in water that the dolphin can hear. If you want the smallest wavelength, what will you choose? You will choose the highest frequency. If you want the smallest wavelength, you will choose the highest frequency. Perfect. Highest frequency हमने ले ली. ठीक है. Now, you will say what? V is equals to F lambda. Velocity is 1500. Largest frequency is 140,000. What will your smallest wavelength be? 1500 divided by 140,000 is your wavelength. Wavelength का क्या आंसर आ गया? Wavelength comes out to be 1.1 into 10 raised to the power of minus 2. Wavelength comes out to be 1.1 into 10 raised to the power of minus 2 meters. Simple as that. Nothing complicated here. ठीक है. The power supply in a
हाँ
circuit is.
सर. सर वो
हाँ हाँ.
जो पिछला क्वेश्चन था रेयर फ्रैक्शन वाला, उसमें मैंने लिखा है द रीजन विद लेस कंसंट्रेशन. तो ये ना मार्किंग स्कीम में लिखा है ना आपने लिखा है, लेकिन
हाँ तो ये
कंसंट्रेशन.
कंसंट्रेशन बेटा केमिस्ट्री का वर्ड है. दिस वुडंट अप्लाई टू फिजिक्स. यहाँ पे आप लिखते हैं ना कि अगर रीजन वेयर मोर मॉलिक्यूल्स आर प्रेजेंट, तो फिर भी शायद एग्जामिनर मार्क दे देता, लेकिन कॉन्सेंट्रेशन पे तो पक्का मार्क नहीं मिलेगा, तो गारंटीड है, जीरो मिलेगा यहाँ पे। और क्या
ठीक
सवाल है सर? अपर इधर डेंसिटी, हाँ कह सकते हो, यस यू कैन से दैट। The power supply in a circuit is made from several cells, each with an electromotive force. Perfect. Each with the same electromotive force. Okay. The cells are connected in parallel. Explain what is meant by electromotive force. Beta, what is meant by electromotive force? Energy per unit charge. Energy per unit charge. In doing what? In driving a charge around a complete circuit. You will say, what is electromotive force? Energy required per unit charge, or energy per unit charge, per unit charge in driving, in driving a charge through a complete circuit, in driving a charge through a complete circuit. Perfect. Let's further move ahead. State one advantage of using several cells in parallel rather than a single cell as the power supply. Okay. बेटा सेवरल सेल्स इन पैरेलल का क्या एडवांटेज होगा? इट लास्ट फॉर अ लॉन्गर ड्यूरेशन ऑफ टाइम, इट लास्ट फॉर अ लॉन्गर ड्यूरेशन ऑफ टाइम, इट लास्ट फॉर अ लॉन्गर ड्यूरेशन ऑफ टाइम। परफेक्ट, चलो आगे बढ़ते हैं। लेट्स मूव अहेड। The power supply is connected in series to a resistor of 4000 ohms and a thermistor. Perfect. There is a voltmeter connected in parallel with the resistor. Perfect. Figure 5.1 is the circuit diagram. Perfect. The temperature of the thermistor increases. Perfect. The temperature of the thermistor is increased. Explain what happens to the reading on the voltmeter. What will happen to the reading on the voltmeter? Yeah. What will happen to the reading on the voltmeter when your thermistor temperature increases? So as the temperature of the thermistor increases, what will happen to the resistance of the thermistor? The resistance of the thermistor will decrease. As the resistance of the thermistor decreases, what will happen? The voltage across the thermistor will also decrease. As the voltage across the thermistor decreases, what will happen? The voltage across the voltmeter increases. Simple as that. Nothing complicated here, but a बहुत easy answer. So you can write it for 3 marks like this. You can say resistance of a thermistor decreases. The resistance of the thermistor decreases. decreases. This causes this causes the voltage across thermistor to decrease. Across thermistor to decrease. And hence the voltage across the voltmeter increases. Hence the voltage across the voltmeter increases. Perfect. Simple. The EMF of the power supply is 1.5 volts. Perfect. Calculate the reading on the voltmeter when the resistance of the thermistor is 8000 ohms. Beta, EMF of the power supply is what? 1.5 volts. Perfect. You have to calculate the reading on the voltmeter when the thermistor has a resistance of 8000 ohms. Perfect. बेटा अगर थर्मिस्टर की रेजिस्टेंस 8000 ओम्स होगी, अगर थर्मिस्टर की रेजिस्टेंस 8000, चलो हेयर आई रिवाइज वन थिंग जो हमने क्लासेस में पढ़ी है, बट चलो वापस रिवाइज करते हैं। Whenever you have to calculate voltage in a series electrical component, whenever you have to calculate voltage in a series electrical component, you apply the voltage divider rule. You apply the voltage divider rule. What does the voltage divider rule states? बेटा वोल्टेज डिवाइडर रूल क्या कहता है? Voltage divider rule basically states that the voltage across a component will be equal to what? The resistance of the component divided by the total resistance multiplied by the total voltage. बेटा voltage divider rule basically क्या कहता है? What does the voltage divider rule states? That the voltage across a component is equals to what? The resistance divided by the total resistance multiplied by the total voltage. ठीक है? अब बेटा यहाँ पे रेजिस्टेंस क्या है? आपके कंपोनेंट का रेजिस्टेंस क्या है? अगर आप देखो तो कंपोनेंट की रेजिस्टेंस क्या है? थर्मिस्टर की रेजिस्टेंस क्या है? 8000. व्हाट इज द टोटल रेजिस्टेंस? 8000 प्लस 4000, 12000, multiplied by the total voltage, that is 1.5. This becomes 2, this becomes 3, this becomes 1, this becomes 2. The voltage, 1 second, ये हमने क्या किया? 2 3, हाँ सही, sorry my bad. This becomes 2, this becomes 3, this becomes 1, this becomes 2. So the voltage across the thermistor is 1 volts. बेटा ये सबको समझ आया? Give me a heads up in the chat, please please please, ये important है. वोल्टेज डिवाइडर रूल समझ आया सबको? दूरदर्शन, रयान, अब्बास, अब्दुल। देखो एएस लेवल में भी वोल्टेज डिवाइडर रूल यूज़ होना है, यहाँ पे भी यूज़ होता है। मोस्टली स्टूडेंट्स इसको रट्टा मारते हैं, मोस्टली स्टूडेंट्स इसको रट्टा मारते हैं। मैं तुम लोग को एक बहुत ब्यूटीफुल चीज़ दिखाने वाला हूँ, इफ़ यू कैन अंडरस्टैंड इट, बहुत अच्छा काम हो जाएगा। देखो आई एम अबाउट टू शो यू कि वोल्टेज डिवाइडर रूल भी याद करने की ज़रूरत नहीं है। अच्छा फर्स्ट ऑफ ऑल तो वोल्टेज डिवाइडर रूल यूज़ का होता है? It is used when you have to calculate the voltage across a resistor in a series circuit. It is used when you have to calculate the voltage across a resistor in a series circuit. अच्छा बेटा वोल्टेज डिवाइडर रूल भी कोई इतना कोई डिफिकल्ट रूल नहीं है। वाई? क्योंकि वोल्टेज डिवाइडर रूल निकला किस तरह से, अब देखना तुम लोगों को मजा आएगा फिजिक्स में। If you see here, if you see here, this 1.5 volts का voltage, this 1.5 volts का voltage that is known as total voltage is being supplied to the entire circuit, which have a total resistance of what? 4000 plus 8000. Let's label this as 12,000. This is your RT. Now according to ratio method, what will be the voltage VR supply to this 8000 ohm resistor? Hmm. What will be the voltage supplied to this 8000 ohm resistor? क्या मैं इन वेरिएबल से एक फॉर्मूला बना सकता हूँ? यस, क्रॉस मल्टीप्लाइड बेटा, क्रॉस मल्टीप्लाइड। वी आर इंटू आर टोटल इज इक्वल टू वोल्टेज टोटल इंटू रेजिस्टेंस, डिवाइड रेजिस्टेंस टोटल टू द अदर साइड। समझ आ गई वोल्टेज डिवाइडर रूल किस तरह ड्राइव हुआ है? मैंने सर ऐसे ही करता हूँ, आई नेवर लर्न दिस फॉर्मूला, भर के पता भी नहीं था। वेरी गुड शाबाश। दिस इज द लॉजिक बिहाइंड दिस फॉर्मूला। कोई भी कॉम्प्लेक्स साइंस नहीं लगती। देखो फिजिक्स सबसे इजी साइंसेस है इफ यू अंडरस्टैंड थिंग्स, और सबसे मुश्किल है अगर रट्टे मारोगे। तो यू कैन, नो ये याद करने की जरूरत नहीं है, इफ यू कैन रिमेंबर दिस रेशो मेथड। और अगर रेशो मेथड भी नहीं लगाना, बिल्कुल ही मतलब कुछ भी समझ नहीं आ रहा क्या करोगे, इफ यू डोंट वांट टू अप्लाई रेशो मेथड एज वेल, क्या करोगे? You know the voltage, you know the total resistance. This is an alternate method. This is an alternate method. What will you do? You know the voltage, you know the total resistance. So voltage is 1.5 volts, total resistance is 12,000 ohms. Can you calculate the current in the circuit? V is equals to IR. Can you calculate the current in the circuit? Yes. 1.5 divided by the total resistance 12,000 is equals to your current. निकाल लो भाई current. This comes out to be 1.25 into 10 is the power of negative 4 ampere. Now you have the current that is 1.25 into 10 raised to the power of negative 4 ampere. The current will remain same in the thermistor. Can you calculate the voltage of the thermistor? V is equals to I. Our current is 1.25 into 10 raised to the power of minus 4 into 8000. What does your answer comes out to be? Answer again comes out to be 1 volts. Simple, simple. Nothing complicated here. Let's move ahead. A primary coil of a transformer is connected to the main supply. Perfect. The voltage of the AC main supply is 240. Figure 6.1 shows the arrangement. Okay. This is the primary coil connected to a main supply. This is the iron core. This is the secondary coil. Explain why a voltage is produced in the secondary coil. Beta, why is a voltage produced in the secondary coil? What will you say? What will you say? बताता हूँ. I will tell about this in the क्या होता है यार वो ग्रुप में बताऊंगा. अच्छा. What will you say here? You will say, explain why a voltage is produced in the secondary coil. What will you say? The magnetic field strength or the magnetic field lines. Field lines cut, or you can say magnetic field lines of the primary coil. Of the primary coil. Of the primary coil. Cut with the secondary coil. Perfect. The magnetic field line of the primary coil cut with the secondary coil. What happens then? The magnetic field lines of the primary coil cut with the secondary coil. What happens then? This induces. This induces what? This induces what? This induces a voltage in the secondary coil. This induces a voltage in the secondary coil. Simple as that. Nothing complicated here. Acha, there are 5,600 turns on the primary coil of the transformer and 350 turns on the secondary coil. Calculate the output voltage. We have to calculate the output voltage. Beta, which formula will, oh sorry, we have to calculate Vs. Which formula will we apply? We have to calculate Vs. Which formula will we apply? Np over Ns is equals to Vp over Vs. Perfect. What is the number of primary turns? 5,600. Perfect. What is the number of secondary turns? 350. What is the primary voltage? 240. Perfect. What will be your secondary voltage? Vs. Can you calculate that? Yes. 5,600 divided by 350. Perfect. 240 divided by answer. Your secondary voltage comes out to be 15 volts. Your secondary voltage comes out to be 15 volts. आगे बढ़ते हैं भाई. Let's move ahead. The output of the transformer is connected to a 90-volt filament lamp which operates at normal brightness. Calculate the current in the lamp. We have to calculate the current in the lamp. We will do what P is equals to IV. Power is equals to 90. Voltage is 15. What will your current come out to be? Current comes out to be 6 ampere as your answer. Simple as that. Let's further move ahead. Copper is sometimes chosen as a material to make pans for heating. अच्छा. Now you will see section B here. बेटा section B अब नहीं आता. Paper format has changed. बस सवाल देख लो. You don't need to be concerned about section B or section C. So what do we have here? What do we have here? थोड़ा सा देखते हैं. Copper is sometimes chosen as a material to make what? To make pans for heating liquids. Perfect. A copper pan contains water at room temperature. Perfect. The top surface of the water in the pan cools as the water evaporates. A convection current causes the rest of the water to cool. Explain how this convection current is produced. We have to explain how this convection current is produced. So what will you say? The surface water cools and it contracts. The surface water cools and the molecules come closer together. You can say the water the water at the surface cools and molecules come closer together. Come closer together. Simple as that. The water at the surface cools and molecules come closer together. This causes this causes the this causes the what? This causes the density of water at the surface to increase. This causes the density of water at surface to increase. The more dense water sinks to the ground, more dense cooler water sinks to the ground, more dense cooler water, cooler water sinks to the ground, sinks to the ground, and hot, less dense water, less dense water arises. This develops a convection current. This develops a convection current. Simple as that. A copper pan is now placed on a hot plate that is switched on. Name the process by which thermal energy passes through the base of the metal. Name the process by which thermal energy passes through the base of the metal. Conduction. Why? Because the base of the pan is made of a metal that is known as copper. Hence, heat transfer in metals is done through conduction. Copper remains a solid when heated up to 1000 degrees centigrade. State one reason why it is sensible to make a pan out of copper. बेटा कॉपर से हमें पैन क्यों बनाना चाहिए? Because it is a good conductor of thermal energy. Because it is a good conductor. It is a good conductor of thermal energy. Perfect. आगे बढ़ते हैं. Let's move ahead. Now let's move on to part C. बेटा part C पे चलते हैं. If you see part C, ठीक है. If you see part C, you have a water in the pan at 17 degrees centigrade. Okay, this is your initial temperature of water. It starts to boil. This is your final temperature. The specific heat capacity of water is this. And the pan contains 750 grams of water. This is the mass of water, that is 0.75. Perfect. You will convert this into kg. Why will you convert this mass into kg? Because the specific heat capacity is also given in kg. Calculate the energy needed to increase the water from 17 degree to 100 degree centigrade. You will say energy Q is equals to mc delta T. What is the mass? 0.75. Specific heat capacity is 4200. What is the change in temperature? 100 minus 17. This comes out to be what? 0.75 into 4200 into 83. This comes out to be 260000 joules. Simple as that. You can also convert it into standard form. You will get the marks either way. Let's further move ahead. State two ways in which boiling differs from evaporation. But you have to state two ways in which boiling differs from evaporation. Boiling only occurs at a specific temperature. Boiling only occurs at a specific temperature. Okay. And boiling only boiling happens throughout the liquid. However, evaporation happens only on the surface. So you can write these two differences. First of all, you can write boiling happens only at a specific temperature. Only at a specific temperature. Perfect. What will you write about evaporation next? You will say evaporation happens only at the surface, happens only at the surface. However, boiling happens throughout the surface. However, boiling happens throughout the surface, throughout the liquid. However, boiling happens throughout the liquid, throughout the liquid. Perfect. Let's further move ahead. At 100 degrees centigrade, the temperature of the water stops increasing even though the energy is being still transferred to the water. Explain in terms of molecule. You have to explain in terms of molecule. Perfect. Why thermal energy is needed to change the state of the water from liquid to gas. बेटा हमने liquid से gas में state change करने के लिए why do we require energy? Because work is done against the intermolecular forces of attraction. Because work is done against the intermolecular forces of attraction so that the molecules move away from each other. You can say the energy is utilized, or the thermal energy, you can write it here. Thermal energy is utilized to do work done against intermolecular forces and move the molecules away from each other. And move the molecules away from each other. Now, the fourth part, I can see this is not in the syllabus. This is no longer in the syllabus, so cross this out. This is no longer in the syllabus. Let's further move ahead. An uncharged plastic rod is rubbed with an uncharged woolen cloth. As a result, the rod becomes negatively charged. Take care. You have an uncharged plastic rod that is rubbed with an uncharged woolen cloth. As a result, the rod becomes negatively charged. Perfect. Explain in terms of particle how the rod becomes charged and what happens to the cloth. Okay, so you have to explain what happens to the rod and how does you have to explain what happens to the cloth. एक second bhai. Beta, because last part is not in the syllabus. Latent heat of vaporization has been removed from the syllabus. Explain in terms of particles how the rod becomes charged and state what happens to the cloth. You have to explain how the rod becomes negatively charged and how what happens to the cloth. So what will you say? What will you say? Electrons are transferred transferred from the cloth to the rod. This makes the rod negatively charged. Perfect. Since since cloth loses electrons, loses electrons, it becomes positively charged. It becomes positively charged. Simple as that. Let's further move ahead. Figure 8.1 shows a metal sphere on a plastic stand. Perfect. Explain why metals are electrical conductors and plastics are electrical insulators. Beta, why are metals electrical conductors and plastics are not electrical conductors, or you can say electrical insulators? What will you say? What will you say? Metals have metals have free electrons, which help in conduction. However, 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 plastic does not have do not have plastic do not have or does not have free electrons. Hence, they are electrical insulators. Hence, they are electrical insulators. Simple as that. Let's further move ahead. The negatively charged plastic rod is held above a sphere X. Perfect. The negatively charged plastic rod is held above a sphere X. Figure 8.2 shows it does not touch the sphere. Perfect. By drawing on figure 8.2, show the distribution of charge on X. You have to show the distribution of charge on X. How will you show the distribution of charge on X? First of all, you will make sure there are equal number of positive and negative charges. Positive charges will be attracted towards the negatively charged rod, that is towards the top side. Negative charges will repel and will come to the bottom side. Simple. An earth wire is now connected to the metal sphere as shown in figure 8.3. Perfect. An earth wire is now connected to the metal sphere as shown in figure 8.3. Perfect. What will happen? State and explain what happens to the charges on the sphere as the earth wire is connected. What happens? Negative charges flow into the ground. You will say negative charges flow into the ground or flow into the earth. You will say negative charges flow into the ground. Negative charges or electrons flow into the ground. Simple as that. Let's further move ahead. Now let's see this. The earth wire in two stays connected to the metal sphere. Perfect. Describe the distribution of the charges on the sphere. The earth wire in two stays connected to the metal sphere. Describe the distribution of the charges on the sphere. Perfect. So, beta, what is happening? The earth wire is still connected. What will happen to the distribution of charges in the sphere? Yes, any idea, geniuses. The top of the sphere will remain positive. See, earth wire connected रहेगा इसका मतलब क्या है? Earth wire connected रहेगा इसका मतलब क्या है? Negative charges will keep on flowing to the downside. Only the top region of the sphere will be positively charged and the bottom region will be neutral, or you can say uncharged. You can say the top region of the sphere is positively charged, is positively charged. However, the bottom region is neutral or uncharged. However, the bottom region is neutral. Perfect. Let's further move ahead. The earth wire is disconnected from the sphere and then the negatively charged is moved away from the sphere. ठीक है बेटा अब आपने earth wire भी हटा दिया है negatively charged rod भी हटा दी है. Explain what happens to the charges on the sphere as the charged rod is moved away. Beta, what will happen to the charges on the sphere as the charged rod is moved away from this? अगर आप नेगेटिवली चार्ज रॉड रिमूव कर दोगे यहाँ से, इफ यू रिमूव द नेगेटिवली चार्ज रॉड फ्रॉम हियर, you also remove the earth wire, what will happen? You will only have like charges. You will only have like charges left in the sphere. You will only have like charges left in the sphere. And like charges repel and spread out. Like charges repel and they will spread out uniformly over the surface of the sphere. You can write this out. You can write this out. Like charges, like charges will repel, and spread throughout the surface of the sphere. Throughout the surface of the sphere. Of the sphere. Perfect. Let's see ahead. A second metal sphere Y is negatively charged. There is an electric field surrounding Y. Perfect. There is an electric field surrounding Y. State what is meant by electric field. What is meant by electric field? A region of a space where an electrically charged particle experiences a force. Region in a space. Region in space where a charged particle experiences a force. Where a charged particle experiences a force. Simple as that. Nothing complicated. Let's further move ahead. Figure 8.4 shows a negatively charged sphere. The negative charges are not shown. On figure 8.4, draw the pattern and mark the direction of the electric field line surrounding a sphere by. You have to draw the electric field lines key direction. Since this is a negative charge, what will happen? Since this is a negative charge, electric field lines will go inside the charge. Since this is a negative charge, electric field lines will go inside the charge like this. Perfect. Like this. Like this. Like this. And like this.
सर
हाँ हाँ बोलो बेटा.
मैंने इसमें सिर्फ चार तरफ से बनाया था, डायगनली नहीं बनाई, ठीक है।
डायगनली बनाना बेटा एहतियातन ज़रूरी होता है. इट इज़ प्रेफर्ड दैट यू ड्रॉ इट डायगनली एज वेल.
ओके।
जितना अपने पेपर को और एक्स्ट्रा अच्छा करोगे यू विल गेट एक्स्ट्रा अप्रिसिएशन फॉर द एग्जाम. तो ये आ गया आपका दिस. Perfect. Now you can make the arrows in the middle here as well. यहाँ पे ज़रूरी नहीं है एंड पे बनाओ. You can make the arrows in the middle as well. Okay, protactinium 23491 is a radioactive isotope of protactinium that decays to uranium 23455. Compare the nuclide notation 23491 with the nuclide notation 23192 and deduce what shows about what is emitted from the nucleus of a protactinium as it decays to uranium 234. बेटा प्रोटैक्टियम यूरेनियम में चेंज हो रहा है. What is happening? Mass number is unchanged. So alpha particle is not emitted. Perfect. Is a beta particle emitted? Yes. Why? Because your proton number goes from 91 to 92. Your proton number is increasing by 1. Beta particle is emitted. Perfect. Is an alpha particle emitted? Is a gamma particle or a gamma ray emitted? No. Sorry. Is a gamma ray emitted? It is not possible to tell. Why? Because gamma has a charge of zero, mass of zero. Even if it is emitted, how will we know? Neither the charge changes nor the mass changes. The most abundant isotope of protactinium is protactinium 231. Explained by referring to their nuclear compositions, why protactinium 231 and 234 are both isotopes of the same element. Why are they isotopes of the same element बेटा? ये दोनों isotopes of the same element क्यों है? Because they have equal proton numbers. They have equal proton numbers of what? Proton numbers of 91. They have equal proton numbers of 91. Explained by referring to their nuclear composition why protactinium 231 and protactinium 231 are different isotopes of the same element. बेटा isotopes different क्यों होते हैं? Because they have different number of neutrons. Because they have different number of neutrons. Because they have different number of neutrons. Number of neutrons. Simple as that, nothing complicated here. A teacher places a radiation detector on a bench in a school laboratory and switches it on. The teacher measures and records the background radiation count rate. Describe what is meant by background radiation and state two significant sources of the count rate recorded by the teacher. बेटा background radiation क्या होता है? Count rate that is always present in the environment. Count rate or radiation that is always present in the environment. Count rate or radiation that is always present in the surrounding. That is always present in the environment. Perfect. You have to tell two sources of background radiation. You have to tell two sources of background radiation. Cosmic rays and what else? Cosmic rays and you can say maybe air में radon का होना. You can say that. You can say cosmic sources and maybe you can say the earth की crust as well. Cosmic sources and earth crust. Cosmic sources and earth's crust. You can rephrase it like this. Cosmic rays लिख दो. Sources ना लिखो. Cosmic rays and earth's crust. Let's further move ahead. The teacher moves a sample of protactium 234 so that it is next to the detector. Suggests one precaution that ensures that the sample is moved in a safe manner. You can use a lead box. You can use a lead box to move the sample. Use a lead box to move a sample. Lead box to move the sample. Perfect. Let's move on to part 3. The count rate is measured every 20 seconds with the sample present and then corrected for background radiation. Perfect. Figure 9.1 shows a graph of the corrected count rate against time for the protactium 234 sample. Perfect. बेटा count rate versus time का graph given है. The curve is the best fit line. Explain why many of the crosses do not lie on the curve. Beta, why do many of the crosses do not lie on the curve? Because radioactivity is a random process and hence measurements fluctuate. You can say radioactivity is a random process. Hence, radiations or measurements fluctuate. Simple. Let's further move ahead. Use figure 9.1 to determine the half-life of protactium 234. Show your working. Perfect. So what will we do? We will go to time t is equals to 0. At time t is equals to 0, beta, what is the count rate here? At time t is equals to 0, what is the count rate here? This count rate is 58. Now, when this count rate halves, when this becomes 29, what will be your time? A count rate of 29 is somewhere here. A count rate of 29 is somewhere here. So you can see, yeah, this will be your time. This will be your time. ये बेटा 60 seconds है. This will become 64. This will be, middle value will be 66. So the half life is 66. How will you show your working? You will say, आप क्या कहोगे बेटा? What will you say? You will say initial count rate. Count rate is equals to 59. After one half life, sorry, this is 58, my bad. This is 58. After one half life, the count rate becomes 29. Perfect. Time taken. Time taken for count rate to go from 58 to 29 is what? Time taken for the count rate to go from 58 to 29 is what? 66 seconds. This is your half life. The uranium 234 ore formed from the protactium is also radioactive. Its half life is many thousand of years. Explain why the radiation from uranium 234 does not affect the count rate measured in this experiment. Because since the half life of uranium is very large, hence it decays very, very slowly. Since the half life of uranium is very, very large, it has a very slow decay rate. Simple. So the count rate of uranium is not affecting the count rate in the graph. So you can say here half life of uranium 234 is very large. Hence, it decays slowly. Simple as that. Any confusions here, any ambiguities in this paper, you can ask.